low noise amplifier is an electronic amplifier used to amplify very weak signals. Essentially, an Lna amplifies signals that are barely recognizable without adding a lot of noise, as the name implies. An Lna is usually located close to the signal source in order to reduce losses in the feedline or minimize interference. This arrangement is frequently used in microwave systems such as GPS, because coaxial cable feedline has high loss at microwave frequencies. For example, 10 feet of RG-174 coaxial cable has a loss of 3.2 decibels at 1 GHz. The feedline would degrade the signal-to-noise ratio by 3.2 decibels. An Lna is a key component at the front end of a radio receiver circuit. Per Freie formula, the overall noise figure of the receiver's front end is dominated by the first few stages. Using an Lna, the effect of noise from subsequent stages of the receive chain is reduced by the gain of the Lna, while the noise of the Lna itself is injected directly into the received signal. Thus, it is necessary for an Lna to boost the desired signal power while adding as little noise and distortion as possible. This enables retrieval of the signal in the later stages of the system. A good Lna has a low NF, enough gain and should have large enough intermodulation and compression point. Further criteria are operating bandwidth, gain flatness, stability, input and output voltage standing wave ratio. For low noise, the amplifier needs to have a high amplification in its first stage. Therefore, JFETs and HEMTs are often used. They are driven in a high current regime, which is not energy efficient, but reduces the relative amount of shot noise. Input and output matching circuits for narrow-band circuits enhance the gain. Lna Design, low-noise amplifiers are the building blocks of any communication system. The four most important parameters in Lna Design are, gain, noise figure, non-linearity and impedance matching. The design for Lna is based mainly upon the S parameters of a transistor. The steps required in designing an Lna are the following. Model. Broadly speaking, there are two large categories of transistor models to enable the design of low-noise amplifiers with standard circuit design simulators, the small signal models and the large signal models. An small signal S-parameter model is a set of S-parameter measurements at different frequencies, but typically at a fixed bias point for the modeled device, which does not require any type of external biasing for preliminary simulations. Large signal device models are a more physical representation of the physical transistors, and to those an external bias must be applied. The majority of discrete surface mount transistors provide small signal S-parameter models, as they can be sufficient for Lna design. Transducer. One of the crucial stages in designing a low-noise amplifier is proper selection of a transducer. The transducer selected should have a maximum gain and minimum noise figure, NF. Stability check. While designing any amplifier, it is important to check the stability of the device chosen, or the amplifier may function as an oscillator. For determining stability, calculate Rowlett stability factor, using S parameters at a given frequency. For a transistor to be stable, parameters must satisfy K greater than 1 and A